So we're in your chemistry book in chapter 1, and we're getting into significant figures, sig figs. So understanding these significant figures. Well, what is a significant figure? Well, it actually is when you have to round because of the uncertainty of a certain number. You have to round it. And you have to know where do I round this number? So when you do it on your calculator, you think, well, which of these, how do I round it to 6.35, or do I keep it as here? Is this significant, or what are the rules in how I can round it, or do I keep this long big number on a calculator? So significant figures allow scientists and engineers to distinguish between the measurements that are very precise and those that are more uncertain. And they want to get rid of the certainty. A number of rules that can use to determine how many significant figures are in the given number. So these are rules you need to know. All non-zero digits are significant. Any certain number is going to be significant. So zeros at the beginning of a number are never significant. Any zeros at the beginning are never significant. Number 3, zeros between digits are significant. Yep. And number 4, zeros that are at the end of the number that has a decimal point are significant. But if it doesn't have a decimal point, they're going to be not significant. So here we have all these zeros are going to be significant here because there's a decimal point. These 2 zeros are going to be significant, but the ones before, this one will not be significant. So far, you just know it. It's all about where the zeros are, really. So let's go on to the next page here. There's another rule here I have to cover. Zeros at the end of a number that does not have a decimal point are not significant. So these 3 zeros on 1,000 are not significant. This 50, that zero is not significant, and that's not significant. So now we have to go by the numbers. Well, let's go for the examples so that we can understand which numbers are significant and how many sig figs each one of these numbers have. It gets kind of fun, actually. So we're going to look at this A first. This number, okay? We know that all the zeros before the 7, all these zeros are not significant. So, but these zeros are significant because of the decimal point. So we have the number 7 is significant and 0, 0. So there's 3 sig figs. Okay? This number here, 8004, 8004, these 2 zeros are significant because they're in between, right? So there's 4 sig figs here. 1, 2, 3, 4. How about 70,000? Well, there's not a decimal point here. So that means that the only significant figure in this figure is going to be the 7. If there was a decimal point, these would be significant, but not so if there's not a decimal point. So only number is going to be significant is the 7. Now this number has a decimal point there, 2,500. So it has 1, 2, 3, 4 sig figs. And of course this number E, 1, 2, any number is going to be significant. So you have 2 significant figures in that. Okay? So sig figs and calculations. So now we have to figure out, when you calculate everything out, where do you need to put it? So for example, if you're calculating the density of an object with a mass of 50 grams and a volume of 7 cubic meters, then you should not express the quotient as 7.142857 on your calculator. Such a quotient has 13 sig figs, where each of the original members has only 1 significant figure. Thus, the result should be rounded to that 1 significant figure, right? So let's find out when you're making calculations. Let's look at what there are examples here. So a sum or difference may not express less uncertainty than the least certain number. Therefore, in addition and subtraction, round your answer to the place that has the greatest uncertainty. Initially, you may find it helpful to draw a vertical line after the place with the greatest uncertainty and round the answer to that place. So we look here. We have 4 sig figs, and of course you lined up your decimal point to add it. And you have 4 sig figs, and here you have 4 sig figs here, and then you have 1, 2, 3, 4, 5 sig figs, but here we round it to the greatest uncertainty, right? And so they put a line here. Well, let's go ahead and we add it. We get this number here. So now the greatest uncertainty would be round, right? So we have 81.06 and you have 0.19. So that basically putting the greatest uncertainty here, this line here, we can round it to 81 and we can round that 19 off and we can have 81.06. So these zeros are not significant at the end. So if they're not significant at the end, then we need to put our line there, and then basically 18.5 for so we put the line of uncertainty there. But anyway, as we do it for, we end up, we wanted, these are not significant, so we need to have these 2 sig figs. So we look here, 2 sig figs, right? 61.00. We round this to 61. 66.16, going to round it all to 61. This has 2 sig figs and this has 2 sig figs. You got it? Okay. So let's go on to the multiplication. In multiplication and division, round your answer to the same number of significant figures as the factor having the smallest number of sig figs. So basically here you have this number here, 63.1, you have 1, 2, 3 sig figs, 0.001 sig fig, and down here you have 144.05 sig figs. Okay, and so now you, as you multiply this out, this is the number you get, 0.0013141. So answer though now cannot have more than 1 sig fig because the smallest number was this one. So we have to round this all the way to 1 sig fig. So we have to round it to the 1. So we round it 0.001, or 1 times 10 to the negative 3 has 1 sig fig. Okay, here's another one. 6.2 has 2 sig figs, and this is 4 sig figs at the bottom. So we have to go the least number, so we want 2 sig figs when we're done. So if you divide this out, you get 1. Well, 1 is only has 1 sig fig, and we want 2 sig figs. So we add a decimal point, 0. Now we have 2 sig figs to the least one. Okay, so you got that? Significant figure apply to measure quantities if the exact number is used in calculations. Okay, for example, so you don't use significant figures. For example, the number of feet in 3.46 yards should be expressed as 10.4, not 10 feet, 1 sig fig, since 1 yard equals exactly 3 feet by definition. So anyway, what they're saying here is that if you're using calculations here, we've got 3 sig figs of the yards here. So that times 3 feet over 1 yard exact here. And so now we want to round to 3 sig figs. So 1, 2, 3. So we round it to 3 sig figs. You should avoid rounding answers to significant figures until your calculations is complete. So, all right. So I hope you can understand that sig fig thing here. So it goes on to problem solving strategies. Let's go over those really quick here. These are actually pretty easy here. So you can see 5 basic steps. Study the problem to be sure you understand it. What is known? Where am I? You will need to do more than just skim the problem, but what do they want in the problem? Number 2, write down what you're given and leave a space and write down the new information that the problem asks for. Where am I going? As you solve the problem, keep your sights on the answer to which you are working. So, number 3. Decide how to solve the problem. Determine what bridge will get you there. What is the connection between them? Always keep your sights on the goal, the quantity to be determined. The bridge may be equations, relationships between units. You may need to check the text for information not given in the problem. So here it's like a little bridge to the desired information and onto the desired problem. Then you solve the problem. Be sure the units come out write, and pay attention to the scientific notation in sig figs. Check the result. Think about your answer to make sure it makes sense. And given what you know, also check for proper use of significant figures, okay? So, and they say here, we may illustrate this procedure in a problem. Let's look at the problem they give us. What temperature on the Kelvin scale equals 10 degrees centigrade? Okay, we have a formula for this, don't we? We study the problem. What are you given? The temperature in Celsius. So, decide how to get to the known temperatures. Temperatures in degrees Celsius and Kelvins are related by the equation. Temperatures in Celsius equal temperatures in Kelvin minus 273.15, which can be rearranged, to say temperatures of Celsius plus 273.15. So that's the equation that we're going to use now. So we solve the problem up here, the top here. So we solve the problem by putting in the blanks. So Kelvin equals 10 plus 273.15 equals 283.2 Kelvin. What is Kelvin? Remember, Kelvin is a temperature of absolute value. It cannot be a negative number. It has to be a positive number. And that would be, check the result. Is it reasonable? Yes, Kelvin temperature is always positive and greater than the Celsius temperature. Yes. Are significant figures used correctly? Yes, only one decimal is permitted. So only one decimal place is permitted. So 200. So the decimal place here, of course, we have 283.15, but only one decimal point is permitted by the sig figs. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So there we have 283.2. So that's how you, to check to see. So you kind of just look where you're going. Problems and units of measurement. A measurement must always have a unit on it, right? Because a measurement without units is meaningless. Likewise, you should always use units with numbers involved in calculation. Also ask yourself what units the final answer should have. When you work a problem, units can be canceled, just like we did in the last lesson. If the units do not work out, the setup is most likely incorrect. It has to be, the units have to work out. It has to be the correct units. So quantities can be added or subtracted, must be expressed in the same unit. So here we have 65.5 centimeters minus 49.9 centimeters equals 60.6 centimeters. This has to be the same unit, same unit, same unit. 650 milliliters plus 6 milliliters is 650, same units. In multiplication, of course, these have to be the same units or you cannot add or subtract them. Now, multiplication and division, you have 7.9 grams per milliliter and divided by 1 gram per milliliter. Well, first of all, I could get rid of that gram per milliliter, and then you have basically have 7.9 units because the units canceled themselves there. Here's another one, 6.4 milliliters, and then you have written down here, milliliters at the bottom, you have 0.078 milligrams divided by milliliters, so we can cancel those milliliters out. And so when you multiply this out, you'll get 5 grams. It's in grams. Here's 4 liters times 0.84 ATMs. So what are you going to do? With these ATMs, you can't cancel out. You have to leave them there. So you say 3.4 because you multiplied these two things and you got 3.4, and then you have liters times ATMs. So the last one here at the bottom, 10.5 centimeters divided by 3 seconds. And so as you divide this out, you get 3.5 centimeters per second. You got to keep the centimeters and you got to keep the seconds because they won't cancel out. You only cancel out the ones that can cancel out. Okay, so let's go on to next here. This whole part has to do with algebra. So they want you to do literal equations. You want to be able to change the equations around. So here is your equation for density that you need to know. Density, which is the P sign, equals mass over volume. Well, you can change this around pretty easily. So here's the P. Well, the volume here is the bottom. So if you're dividing it, so you multiply it on this side. You always do the opposite on the side. So if you're multiplying, now you have P times volume equal mass. So this is the same equation, only changed around. And now down here, you have volume. So if you have volume here, you can take the P and put the P on there. So you have volume equal mass over P, over density. Mass over density. So see, all three of these are the same thing. They're only changed around by either multiplying. When you divide it on this side, you have to multiply on this side. If you multiply on this side, you have to divide on this side. And so that's the way. So also, before this here, this little equation here. So if you have Q plus W equal delta E. So now we want to know, okay, we want to know what W is. Then we say W equals delta E, and because you added it on this side, you subtracted on this side, the Q, minus Q. These are the same equation, only changed around. Now let's change around this last one here. So we have a rate. This is the square root. So we have a rate equals KA squared. So if we want to know what A is, we want to know, solve for A. So we say A squared equals rate over K, right? Basically, A squared is going to equal rate divided by K, by just putting the K on this side. So, but now we want to know what A is, not A squared, so we have to do the square root of it to find out what A is. Got that? You probably have one of those in the test too. So, we're going to go over the review questions. Let's see. I wonder if we could go ahead and do it now. Might as well see if I could get them done now. Ugh. Let's see if you can see these properly here. I think you can right now. So let's look at this first one. These first ones. We want to just know the number one is to put these in scientific notation. So let's look at these numbers that I've written down here. Okay, A. So we have A here. Sorry, I'm kind of lost my pointer here. So A is 0.0021. So we want to change it to scientific notation. If we look here, we want to move it over so it's right there, because you want to make sure that scientific always has the numbers are between 1 and 10, not including 10, between 1 and 10. So we move these over. So we can move this over 1, 2, 3 places. So we have 2.1 times 10 to the negative 3, because we have negative, because we have a lower number, so it's 10 to the negative 3. Okay, this one, scientific notation, is 10,005. So here we have, now we want to see how many, so we want to do it 1. We want to put the decimal right here, because it has to be between 1 and 10. It can't be 10, so we put it right here. So it's going to be 1 point, and then you 1, 2, 3, 4. So it's going to be 1.005 times 10 to the 4th. Okay, let's do the next one. So we have 0.490. 0.490, we're going to move this decimal point over, so it's 4.9, because that's going to be scientific notation. So we moved it over only one space. So one negative space, because it's a negative. So we have 4.90 times 10 to the negative 1 power. Okay, let's do number D. 445,000. So now we want to change it to, so it's 4.45, because it has to be right here. So we changed to 4.155. Well, here's the decimal. How many places do we have to move it over? 1, 2, 3, 4, 5. So 4.45 times 10 to the 5th would be the scientific notation. Okay? So let's express the following numbers in their expanded form. So now we're going to go do just the opposite. So I hope you can see this good. Okay. So number 2A, 2 2.24 times 10 to the fifth. Well, what's that going to be? We write down 2.24 and then we're going to move that decimal over 5 places. So here it is. 1, 2, 3, 4, 5. So we got 5 places. We've got that is 224,000 right here. That's what that is. And you look at that, 10 to the fifth is going to be a big number, and that is a big number. B, we have 1.5 times 10 to the negative ninth. This is going to be a small number. And so it's 1.5 and we have to move this way. So I just put a whole bunch of zeros there and we're going to move it over 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to have 8 zeros. The first one is a 1, so it's going to have 8 zeros. So it's 8 zeros, and here's the number. That says 1.5 times 10 to the negative ninth. Okay, here we go again. So the next number here is 6.55 times 10 to the negative 1th. So we're going to put down 6.55. So we're going to move it over. Here it is, 6.55. We're going to move it over just negative 1. There we go. So we have 0. I put a 0 before there, so 0.655. We just moved it over 1 place there. D. So we have 9 times 10 to the third. We're going to add 3 zeros here, but here we got the decimal point here. 1, 2, 3, 9,000. Okay. So let's go on to number 3. Perform the following calculation expressing your answers in scientific notation. So this is 3A. This looks like it's going to be complicated, but it's not. So we have these numbers here, 7.4 times 10 to the negative 2, 6.5 times 10 to the negative 4. Okay, there's a subtraction here. Right away, you know, you cannot do this because you have to change these both to the same power. They both have to be either a negative 2 or a negative 4 power. So they must be in the same power of 10. So we changed 7.4 times 10 to the negative 2. And then we changed this to a negative 2. So we had to move over, so we moved it over 2 more negatives. So 6.5 moved over 2 spaces here. So we have minus 0.065 times 10 to the negative 2. So we got 7. Now we have 7.335, because if you subtract 7.4 minus 0.065, subtract that, you'll get 7.335 times 10 to the negative 2. That would be the answer. Okay? So let's go on to, let's see, that was number 3. There we go, some more, 3B. Okay, 3B says, basically here in 3B, you have multiplication now. This is how you multiply. So multiplication, this up here so you can see it better. There we go. So we have 5 times 10 to the 4 and 2 times 10 to the square. So first of all, you take 5 times 2 equal 10. We got that one. And then we take 10 to the 4 times 10 to the 2. Remember, you can add. Whenever you're multiplying exponents, you can add the exponents. So now we have 10 times 10 to the 6. So 10 times 10 to the 6 actually would be 10 to the 7th. Okay? Number C, we are going to do a division program, or division problem. So here we have this division, 7.15 times 10 to the third and 2.5 times 10. So right away we want to kind of divide this up, and we divide this first, we divide the first half right here, 7.15 divided by 2.15. If you do that in calculator, you get 2.86. And then this here, whenever you have division, which you have a division problem, 10 to the 3 minus 3, okay, that's going to equal 0. So here we have, the answer is 2.86. When we divided this out, we got 2.86 times 10 to the 0 power, which is 1, right? 10 to the 0 is 1, so our answer is 2.86, right? 10 to the 0 is always 1. Any power of 0 is 1. So let's go on to the sig figs. See if we can do these. These are all pretty easy. They just want to know how many sig figs. 409, any 0 in between is significant, so we have 1, 2, 3 sig figs. 0.0070. So any zeros before the 7 are not significant. These are not significant. So we have 2 sig figs. 15,000. Well, we don't have a decimal point there, so none of these zeros are significant. So only two sig figs. This number has a decimal point, so that means all these numbers, 1, 2, 3, 4, all of the numbers are significant. 5 sig figs. So here we have a decimal point, and so we have decimal point, which says, so basically we have 1, 2, 3, 4, 5 sig figs. So here we have 5.050. And so with the decimal point, we end up these significant, so we have 4 sig figs, okay? Alrighty, so let's go on to the next, which is number 5. This we're going into how do we add and subtract sig figs, okay? Alrighty. So here we have, if we're doing this, we have 201, 3 sig figs. We have 3.55, 3 sig figs. So, and we have 97.391 sig figs. So we want 3 sig figs. So basically, if we put it down, sig figs, we'll have the answer, adding it out, where to round it to. So do we round it to the 5 sig figs? Actually, we're going to round it to the third, right? So I actually rounded it to the 5th sig fig, but if you round it to the 3rd sig fig, you'll end up 1, 2, 3. So you'll end up with the number 302, right? So B. So here's the subtraction here of sig figs. So as you subtract in the sig figs. So, and now let's go on to, let's see. I don't have much time on here, so I'm kind of rushing here, and you could do some of these. C. Oh, the division of sig figs. Okay, let's do the division. It's always to the smallest sig fig, right? So we have 6.24 divided by 960, 3 sig figs and 3 sig figs. And so as we divided it up, we actually got 0.65. But since there's only 2 sig figs, we need 3 sig figs, so it's 0.650. Okay? So needs 3 sig figs. Okay? So let's go on to D. D number here. So we have 5,000 is 1 sig fig, and we have 0.6041, which again is 4 sig figs. So if you multiply that out, you're going to get this big number here, which is 3205.5000. So now we want to know how many sig figs do I need here? Well, to the lowest sig fig is only 1 sig fig. So we round it to the lowest sig fig, which 3,205 rounds to 1 sig fig, which is 3,000. Okay? So that's the sig fig thing. Let's do this last one pretty quickly here, if I can. 6. A, this is just your algebra thing, changing things around. So we're going to solve for E. So you see this picture, we're going to solve for E1 actually. So you have E2 minus E1 equal HF. So we want to solve for E2 equals E1 plus HF, and you switch that around. You have AT minus HF equal E1, or you can say E1, here's E1 equals that answer. So B. So this is a little bit more complicated here. So you're going to have, see how this P1 and PV over T, P2, V. So now you're going to figure this out. So you're going to solve for, what are you going to solve for? T1. So here's T1. We want to solve for this. Well, this is 1 over T1 equals, and then we put PV1 here at the bottom. So it's P2, V2, T all, and you put these at the bottom. But now since this is 1 over, we want to solve for T. We just do the reciprocal. this reciprocal of this, so this would be our answer, T2 P1 V1 over P2 and V2, right? So you got that answer, huh? The next one, the same way, as you can see here. The only difference here, we're going to solve for P. So we're solving for P, so P delta V, so we put that, so basically P is going to equal these two, and then you end up putting this V down at the bottom. Pretty easy one. Now the square root one's a little bit harder. So here was the square root. So at the end here, we want to know, we found out, we rearranged it all, and at the end we have C2 and the square root of K over AB. So that's it.